Hi everyone. So the question for today is longest consecutive sequence. So herein we see we have an unsorted array. We have to return the length of longest consecutive element sequence. So longest consecutive elements is the elements should be having a difference of one in between them. So a brute force approach of solving this is that, let's say I start with this element and I check if the next consecutive elements are present, for example 101, 102, etc., into the remaining part of the array. And then for every other element I check for the same. So the time complexity would come out to be big O of n square. But our question says that we have to have big O of n time. So let's see how do we solve this. Now in here we see that in our first example we have 104, 200, 132. So the longest consecutive subsequence I can see is 1, 2, 3, and then followed by 4. So that's why the length of the longest consecutive subsequence is 4. So that's why we return this. And then in here, from 0 till 9, 0 till 8 is our longest consecutive subsequence. So then the output is 9 because length is 9. Now in here, our longest consecutive subsequence I can see is 0, 1, and 2. So that's why output is 3, the length of it. Now in terms of I can, these are the constraints, so it is fine. And yeah, so we want to achieve this in big O of n time complexity. So let's I take this example. I'm taking this example for understanding purposes. Now let's say I am at 100 currently. Now if this is a part of some subsequence, in the list we have to check if the next element is present, which is 101. Now we want a way such that we can find this is present in array in big O of one time. If we can do that, we can achieve big O of n time complexity. So the only way we can check this in big O of one time is one way to do this is using a set. So in my set, I can have all these elements, right? Now what will happen is when I check if my set contains 101, it does not contain. So then there is no, sequence of this. Now our next element in the set is 4. So for 4, I'll check if 5 is there or, 6 is there. Since 5 is not there, then we come out. Now for 200, there's no 201. So then we again move to the next element. Then we have 1, right? Now we check if we have 2. Yes, we do have 2. So now we'll go to 2. Now from 2, again, we have to check if we can expand the sequence. So from 2, we'll check if we have 3. Yes, we do have 3. Then from 3, if we'll check if we can expand. So we see we have 4. So that's why we go to 4. Now from 4, do we have 5? No. So this is where we stop. So this 1, 2, 3, 4 is our sequence. And this is in fact the longest sequence we'll see for so far. I'll tell you why. So let's see. Let's go to the next element, which is 3. Now from 3, we'll check if there's another 4, which is there. So we'll go to 4. And from 4, we'll check if we can go to 5, which is not there. So we'll come out of the loop. Now the next element is 2. Now from 2, we'll see if we have 3. And from 3, we'll see if we have 4. And from 4, we'll see if we can go ahead, which is not possible. So you see the longest subsequence is 1, 2, 3, 4. But you see one thing. We also check 1, 2, 3, 4. Then we again check 3, 4. Then we again check 2, 3, 4. And then followed by 4. So is this really required? I mean, if we've already calculated the this subsequence 1, 2, 3, 4, we don't really need these. So how do we avoid these? You see, we will only, start counting the sequence if it is the start of the sequence. Now, 1 is the start of the sequence, so we should be counting this. Okay? So true. It's the start. But Is 3 start of our sequence? No, it's in the middle of the sequence. 1 is the start. So if 3 minus 1 is present somewhere in the set, it means we don't need to expand. We can skip this. We can also skip 2. Why? Because 2 is not the start. 1 is the start. How do we know that? Because 2 minus 1, 1 is present in the set. So we skip this. And now when we come to 4, we also skip this because 3 is there. So now we see instead of 4 comparisons, we only have one comparison for a particular subsequence. So instead of O n square, it becomes big O of 1. I mean n whatever. So big O of n, why? Because it will iterate once through this entire subsequence, and rest of the others are skipped. So that's why our time complexity would be big O of n. So now when we talk about set, let's write the code. So we'll have a set of integer because that's how our nums is stored. Now then, let's say we will have unique numbers in our set, right? So we've named this very meaningfully. Then we have this, not hash, we'll have hash set, new hash set. So yeah, now what we are going to do is we will iterate through the nums array using for each loop. So when we do that, we are going to store every number in unique numbers so that we have a set for every number. So the function we call is add, and then we add a number. Now what happens is we'll again iterate through number in unique numbers. Why unique numbers? I'll tell you why. But before that, what if we want to see longest consecutive sequence, right? So int longest consecutive sequence seen so far is 0. Let's use camel case. And in the end, we have to return this. Okay, now let's come to the fact why have we used unique numbers? The reason is we could have duplicate elements. Now in this array, we see 1. We see once, twice. But what happens if we have multiple zeros here? We'll check with every 0, right? But if you've checked with 1 0, we don't need to check for other zeros. So that's why let's keep iterating using unique numbers. Now we only need to check if we can expand the substring if it is the start of the substring, start of the sequence. So in 1, 2, 3, 4, 1 is the start of the sequence. Why 1 is the start? Because 0 is not there. So it means that if my unique numbers does not contain what? Num minus 1. So it means that this is the start of the sequence. Num is my start of the sequence. Now we'll have an integer variable called current consecutive sequence length. So it will store how far we can expand this sequence. Now we'll initialize it to 1. Why 1? Because num will be there. That's why. Then let's say our current number that we have that we are expanding is now. Okay. Now we'll check if we can expand. How will we check? But before that, this while loop, we'll always keep track of the longest consecutive element seen so far. How will we do that? We'll do that using math.max of longest consecutive subsequence and current consecutive subsequence. So this is how we do it. And yeah. So now our while loop says that if we need to check if we can expand. So how do we check? If my unique number does contain num plus 1. So it means we can expand num. So that's why we'll add num plus 1 to the, we'll add it to the length. So this will increment, and now my num also will be num plus 1. Then we'll check if we can expand num plus 1. So that's why num plus plus. Okay, current num, not num, current num. And here as well, we have current num. Okay, I've done that. And now what has happened is this is the entire code now. Now running this, let's see if the test cases pass. It does pass. Let's say it passes the edge test cases. Yeah, it does pass. Now, coming to the time and space complexity, we see we have a set of integer unique numbers. Now, worst case, what will happen is, let's say n is the number of elements in my array nums. Now, worst case, every element will be unique. Okay, so looking at the constraints, my num dot length is 10 to the power 5, and nums of I is less than or equal to 10 to the power 9, and my in between minus 10 to the power 9 in this. So obviously, every element can be unique, definitely. So that's why we have unique numbers. So my time complexity comes out to be big O of n. Now let's talk about the space. Sorry, this is space complexity. Yeah. So now, because we are storing those unique numbers here, right? Now my time complexity for this loop is big O of n if we have n elements, right? So this loop says big O of n in time. And then we have another loop here, which is it will iterate up until unique numbers. In worst case, we can have n unique numbers. So big O of n here. And then we have another while loop here, which will iterate through the sequence. Now, will this increase our, runtime, time complexity? Actually, no. Why? Because for every sequence, we'll only expand the numbers only once, which is from the start. And since we are doing it on unique numbers, so that is why overall we'll only iterate each number once. But the rest of the elements in the sequence we'll skip. So that's why it will be big O of n. So the total time complexity turns out to be big O of n. So yeah. So this is how it is. Thanks for watching and bye.